Hello, good day everyone. I am here to discuss to you my assigned topic, which is the permutation. All of us here are familiar na about permutations because it is discussed one by one to us in our everyday reports. I've been giving you the definition of the different types of permutations. First is the definition of a group. A group G is a collection of elements together with a binary operation which satisfies the following properties. Na-discuss na po ni sa tuwa per Minister Indangan and ninggawas ni siya actually sa tuwang exam, which is the closure holds, associativity holds, the identity holds, and inverses. Saan man ipagkuhan? Wala. Na maklaro ni siya. A binary operation is a function on G which assigns an element of G to each ordered pair of elements in G. For example, multiplication and additions are binary operations. So familiar na kay taan ning group. Let's proceed to classifications of groups. Groups may be finite or infinite. That is, they may contain a finite numbers of elements or an infinite number of elements. Also, groups may be commutative or non-commutative. That is, the commutative property may or may not apply to all elements of the group. Commutative groups are also called the abelian groups. Example of groups. Infinite abelian. Nara diri ang mga examples nga gi-define sa group. The infinite and abelian. The integers under addition, the integer or the positive and the integer and the positive integer. The rational numbers without zero under multiplication, the rational mo ni siya si q and si x mo ni siya si multiplication. Infinite non-abelian. The general linear groups GLN sa inyong nabantayan sa atong reports, the non-singular NXN matrices under matrix multiplication. Finite and abelian. The integers, mode, and under modular addition. Integer n and the positive addition. Katong Z5, which is katong 0, 1, 2, 3, 4, sa atong table nga atong nakuha. Makuha niyo dito ang examples. The U groups, UN defined as integers less than n and relatively prime to n under modular multiplication. Finite and non-abelian. The dihedral groups D sub n, the permutation or regular n-sided figure under function composition. The permutation group series sub n, the one-to-one and onto functions from a set to itself under function composition. Abelian isn't that one followed by a bunch of zero. Anonymous grad student in math program. Example ba ni siya? Never mind. Permutation group. By definition, a permutation of a set A is a function from A to A, which is both one-to-one and onto. Recall from earlier work, a function from set A to set B is a rule which assigns to each element of A the domain, exactly one element of B the range. One-to-one means FA is equals to F of B implies that A is equals to B. Onto means every element of B is the image of at least one element of A under F. In permutation on set A, the range and the domain of the function are both the set A. Permutation group. A permutation group of a set A is a set permutation on A which form a group under function composition. That is, the elements are functions from A to A which are both one-to-one and onto. And the binary operation is function composition. Recall again, a group has an elements which includes identity and inverses, and an operation which is associative and closed. Here the elements are functions and the operation is function composition, which is always associative, although not usually commutative. So this may take some getting used to because in most of the groups we have seen so far, the elements are values and the operation is a function. So in permutation group, we need functions and their inverses. Also, we need an identity function. So recall from earlier work again that a function has an inverse if and only if it is one-to-one and onto. Since functions are group elements, we expect that a function composed with its inverse will result in the identity function as indeed it does. At this time, we are mainly concerned with permutations on a finite set, so we can build closure into the function definition. So let's proceed again. Permutation group notation. So notations. In other areas such as algebra and calculus, functions are defined on infinite sets and often written as algebraic formulas. However, in this context, we usually define a function explicitly by listing an element on the domain alongside its corresponding function values. So these are the two ways. This is commonly done: grid notation due to Euler and cycle notation due to Cauchy. So example, D4 the symmetries of a square. Consider that D4 the symmetry of the symmetry group of a square. We can represent this group as a permutation group in grid notation as follows. Number the four corners of the square. So 1, 2, 3, and 4 are as shown. So then we can represent a 90 degrees counterclockwise notation as 1, 2, 3, 4, and 2, 3, 4. So R90, that the 90 represents the 90 degrees, is equals to 1, 2, 3, 4 over 2, 3, 4, 1, and a reflection across the horizontal axis as F to the F sub H is equals to 1, 2, 3, 4, and 2, 1, 4, 3. Kung sa cycle notation, R90 is equals to 1, 2, 3, 4, and F sub H is equals to 1, 2, 3, and 4. So series sub 3 and series to the n. Let S3 be the group of all one-to-one functions from the set 1, 2, and 3 to itself. This is same as saying all arrangement or permutations of these three elements. So recall from previous work that the number of permutations in a set n elements is n factorial. So the number of elements in S3 is 3 factorial or 6. So 3 times 2. So 3 times 2 times 1. So in general, S sub n is the set of all permutation in a set of size n, and the order of Sn is n factorial. So Cauchy cycle notation. These joint cycles commute order of a permutation. Cycle notation introduced by Cauchy has main advantages over grid notation. In general, the product of cycle does not commute. However, we can write any permutation as a cycle or a product of disjoint cycles. That is, each element of the set appears in at most one cycle. Written in this form, disjoint cycles commute. Also, when we write a permutation in this form, the order of the permutation, that is the smallest numbers of times we need to repeat that permutation to obtain the identity permutation, is the least common multiple of the length of the cycle. Cycle notation. Any permutation may also be written or decomposed as a product of two cycles. This product would usually not be disjoint and it need not be unique. However, if a permutation can be written as an odd number of two cycles, any other decomposition of two permutation is also an odd number of two cycles. Similarly, if a permutation can be written as an even number of two cycles, any other decomposition of that permutation is also an even number of two cycles. So the identity permutation is always an even number of two cycles. So I'm odd and always be odd. So si Johnny bagay nga ni, di ba? Johnny, anak. So the composition into two cycles, always even or always odd. Identity is always even. So mora na timanan sa cycle notation is 3. So cycle notation again, if a permutation can be written as an odd number of 2 cycles, we say it is an odd permutation. If a permutation can be written as an even number of 2 cycles, we say it is even permutation. So, naragyan akong tuntulugan niya. Example of the composition into 2 cycles. 1, 2, 3, 4, 5, 1, 5, 1, 4, 1, 3, 1, 2. Sa 1, 2, 3, 4, 1, 4, 1, 3, and 1, 2. So, mura na siya gikuan, tipon-tipon. 1, 2, 1, 3, 1, 4, and 1, 5. So, 1, 2, 3, 4, 2, 4, 7. So, 1, 4, 1, 3, 1, 2, 2, 7, and 2, 4. Notice that 1, 2, 3, 4, 5 is a cycle of length 5 and 5 is an odd number. Yet, 1, 2, 3, 4, 5 can be written as an even number of 2 cycles, so it is an even permutation. However, 1, 2, 3, 4, a cycle of length 4 is an odd permutation because it can be written as an odd number of 2 cycles, even though 4 is an even number. Alternating groups of degree n. For any n, the set of even permutation in S sub n forms a group and a subgroup of S sub n. This is because the inverse of an even permutation is always even. The composition of even cycles is always even and the identity can always be written as an even cycle. So kung even siya, even siya. This group is called an A sub n, the alternating group of degree n. When n is not equal to 1, A sub n is of order n factorial over 2. The alternating groups are very important in historical, theoretical, and application contexts. Note that the set of an odd permutation do not form a group because this set lacks the identity permutation and lacks closure under multiplication. So, dili na kay siya composition na So, dili na kayo nato siya ma-explain is because provided na kayo ang mga dapat explain sa atohang PPT. So, that is all. Thank you for watching.